The last aspect of solving equations that we're going to look at are situations where your equation has a variable that's either squared or cubed. And what I mean by squared and cubed would be to the power 2 or to the power 3, right? That's what those mean. An exponent of 2 or an exponent of 3 would be cubed. So for example, you might have a situation where you have an equation that looks something like this. X squared minus 5 equals 4. Right, if that was just straight up x, that would be so easy to solve. Right, you would just add 5 to both sides. But now we've got to go a step further, and we're going to deal with questions that look like that here shortly. But I just want to make sure, first of all, that we have a good understanding of the difference between powers and roots. And so imagine I took, let's take the number 3, and we were to put it to the power 2. Okay, hopefully you remember this from BEDMAS, right? The E in BEDMAS told us how to deal with these exponents. Tells us to do 3 times 3, right? The 2 tells us that there's 1, 2, 3's being multiplied together. So 3 times 3 is 9. 3 squared equals 9. Now, what we didn't really deal with before is how to deal with the square roots, this situation. So imagine, I'm just going to work my way backwards here. Imagine this 9. I'm just going to bring it down here, and I'm going to say, well, how would I work my way backwards to the 3? What's the opposite of squaring something? And the opposite of squaring is this function right here, this operation, which we call not square, but square root. And same thing with cubed. We don't call this cubed, we call it cube root. These are all opposites of each other. If you go across, each one of these are opposites. Okay, so jump back here over to this 9 that we have. The opposite of squaring the 3 that we did up here is to square root our 9. And that should bring us back to our 3. Square root asks us what number, when you multiply it by itself, gives you the number underneath. And think about that. What number, when you multiply it by itself, gives you that number underneath? Well, it's 3, right? 3 times 3, right? When you multiply it by itself, 3 times 3 is 9. So that gives us that number underneath. So the square root of 9 is 3. Now, the one that everyone always misses is there's another option. 3 isn't the only number. You could also do, and this is the tricky one that everyone misses out on, you could also do negative 3. Because what's, okay, 3 times 3, well, hey, that's 9. Negative 3 times negative 3, well, 2 negatives, that make a positive. So it gives us positive 9. So negative 3 is a possible solution over there when we square two numbers. So squaring is the opposite of square rooting. Much in the same way that adding is the opposite of subtracting, right? If we wanted to get rid of something from one side of an equation and it was being added, we would do the opposite, we would subtract. Or if something was being multiplied and we wanted to get rid of it, what would we do? We'd do the opposite and we would divide. Well, now we've got another tool to add to our toolkit. If something is squared, we're going to do the opposite to get rid of the square, and the opposite is to square root that number. And last, let's just take a second to look at cubing something. So if you had the number 2 and you cubed it, right, that would mean 2 times 2 times 2. That would bring you to 8. 2 times 2 is 4. 4 times 2 is 8. The opposite of that, then, would be the cube root of 8. And what that asks us is it says, well, what 3 numbers, when you multiply them together, sorry, when you multiply them by themselves, gives you 8. Right? And when you multiply them by themselves, well, it looks like 2 is going to be that number. 2 times 2 is 4. 4 times 2 is 8. So if you take 3 2's and multiply them, it gives you 8. So the 2 cubed is 8, and the cube root of 8 is 2. So it pays to keep a few of these in mind. So I'm just going to jump and list a few of them. And so imagine we're going to do just a few squares on here. And I'm just going to go up to 10. 8 squared, 9 squared, 10 squared. So if you have a few of these memorized, I find it's kind of helpful. 1 squared, 2 squared, 3 squared, 4 squared, 5, 6, 7, 8, 9, and 10. These should kind of stand out to you. If you see these numbers, they should stick out to you, right? The number 25, you should say, if I were to take 5 and square it, I'd get 25. Now I could create a list very similar to this, where I just take the square root of the numbers here on the right. So I could make a list where I say the square root of 100, what number when you multiply it by itself gives you 100, is 10. And same thing here, 81, the square root of 81 is 9. The square root of 64 is 8. We call these numbers, in this column right here, we call these numbers perfect squares. Because when you take their square root, it gives you a whole number answer. Right? The square root of 64 is 8. It's not 8.1, not 7.95, it's exactly 8. So we call 64 a perfect square. So let's look at how this idea of squaring and square rooting as opposites, let's see how that plays out in an equation. Let's look at an example. Okay, so x squared plus 3 equals 28. We're going to tackle this just like we would questions before. If that was just x plus 3 equals 28, what would we do is we would subtract 3 from both sides. So we're going to do that exactly like we would before. Nothing new. X plus 3 minus 3 equals 28 minus 3. These two cancel. Leaves us with x squared equals 25. Now, nothing new yet. Now we need to get x by itself. The problem with x is that it's not by itself yet. It's being squared. And in order to get rid of the square, right, this 2 up here, we need to do the opposite of squaring. As we said before, the opposite of squaring is square rooting. So we're going to square root both sides of the equation, right? Just like up here when we subtracted 3 from both sides, down in this step we need to square root both sides. And effectively what happens, just like plus 3 minus 3 up here cancel each other out, the square root and the square cancel each other out on this one. So on the left side, we're just left with x. Now on the right, we've got the square root of 25. Well, what is the square root of 25? What number, when you multiply it by itself, gives you 25? Well, looks like 5 is going to be the lucky number. Now, there's also another answer. We could say negative 5 is a possible solution, because you could take 5 times 5 to get you to 25, or you could do negative 5 times negative 5. That's also going to bring us to 25. So there's 2 possible solutions on this type of question. One last thing I'll show here is you can take that and you can check. Right? Do the check step, just like we did before, nothing new. But we're going to put our 5 now, or negative 5, I'll pick 5 just for sake of ease. And we're going to put it in the place of x up in our original question. So it's going to look like this. It's going to be 5, I'll put it in brackets just to be really clear that it's a substitution. 5 squared plus 3 equals 28. Well, 5 squared is just 25, right? 5 times 5. And then 25 plus 3 is 28. 28 equals 28. That tells us that our 5 is correct. And just even really quickly, imagine taking a negative 5 in here instead, right? Negative 5 squared is positive 25. Positive 25 plus 3 is 28 as well. We'll look at a couple more examples, one of them involving cubes in the next video.